All right. So a few clarifications. Anil pointed out to me that you could call sort on this if you wanted to, but the behavior would not be what you would expect. Well, what you would end up with is basically that the firsts would remain unaffected, and the seconds would all get sorted. Which I mean, if you want to sort the entire pair, you need a comparator. Regardless, there's another bug in our code, which is that where value type, reference type, iterator category. No, where's the bug? There's a bug somewhere. Maybe not. Anyway, okay, so we have this iterator basis. Let's expand this to encompass other kinds of iterators. So let's start with bidirectional, right? What do we need for bidirectional iterators? What is the one other operation that one can do on a bidirectional iterator? Yeah, decrement. Decrement. So let's implement decrement for our iterator. It's very easy. Anyone want to tell me? No? Minus, minus? Yes, minus, minus. And we change our tag to bidirectional iterator tag. Yes. All right. Template, yes. Actually, okay, so now this is complicated because, no, it's not complicated. Never mind. Bidirectional. I think I've spelled it correctly. All right, and we need a few more operators in our iterator class. What do we need? Minus, minus. Yes, let's copy all of these and paste. Minus, we call decrement instead of increment, and minus. Oh, this. Okay, we did something here that was unfortunate. We should have used our pre-increment to implement post-increment, which we didn't, which is unfortunate. So let's do that. It doesn't really change much, but let's do plus plus star this, right? Much better. Same thing here. We will do minus minus star this. Okay, I think that's it, right? I don't think bidirectional iterator has anything else. John, is there anything else? That's it. So that's bidirectional. For random access iterators, we need a whole bunch of things. So let's fix the basis first. No, I did that already. What do we need for random access iterators? move by an offset. So let's just call it, it's increment by an offset. So we can overload increment to do that. Or you could define a new function. It doesn't make much difference. What else? Compare, but increment int will do that, because if you want to move to a position, you just say move 5 steps or something.
Right?
One of the things
It means go to position 5, not increment or decrement.
No, but what do you mean by go to position 5? What is position 5?
It's 5 steps from 0.
Yeah, and what is 0? Yeah, I mean the whole point of this is to have a minimal interface. So, yeah. Plus, we don't. This class doesn't know what the beginning is. It doesn't. I mean, depending on what your I is here, right? You could have multiple arrays. Which array do you mean, right? So it's the absolute thing. You cannot implement that here.
So what you can do with a random access iterator is you can do a plus equals some amount.
Mm-hmm.
But you can also use array notation.
You can use array notation.
Allows you to access it without changing it.
Yes.
Do we want to support that directly, or do we just want to make a copy of the base iterator and do the increment and then throw away the copy, which is one way of doing it?
Given that iterators are cheap things, and I mean we want to minimize the surface area here, that's what we would. I mean, and you have to. Yeah.
You just have to make a decision and do it that.
Yes.
And then the other thing we need is what you were hinting at, is we need the inequality operators for less than and greater.
That we'll have to add to our iterator class, but those will be implemented in terms of difference. Basically, we need. If we have two iterators, we can ask what is the distance between them, right? So we can call it distance. We can call it difference. It's the same thing. So let's call it. I don't know, any difference. Let's call it difference. What's more standard?
Is it difference more commonly used for?
And the affiliated type is called difference type, so that makes sense. Yes, that's a very good argument for difference.
But there is also a standard function called
Standard distance. Yes.
They're both standard.
Yeah. Yeah. All right. So difference takes another basis and gives you the distance to that. So we gain some affiliated types here, right? Because this is going to return difference type, sorry. Which means we need another affiliated type. All right, let's write this. That is another question. We could just pass in a negative number to increment to have that happen, right? And in most cases, that is the most natural. I mean, if your underlying iterator is a pointer, you can always a negative number just works, and so let's go with that for now.
What's the y of the difference?
The y is the other guy.
Oh, x, y.
Yeah. Should the increment be of difference type, not int? So the question is, what does the square bracket operator or plus equals actually take? I think it's probably difference type. That's a good point. Yes. Difference type. Yes. Any other questions on the concept requirements? I guess not. All right. So let's implement, we'll change the tag later. Let's implement our increment. Increment takes difference type I, and what does it do? Position. plus equals I. Yes. And we also need to define our affiliated type, which is going to be the difference type of the iterator. Is that right? I need to stop saying the answers. I need to ask questions. Difference type of I is difference type. Of course, I need to define difference type. Template. I think we've covered these before, so I'm not going to explain exactly. You can refer to the older classes to see what's going on here. Using, we should put these in a header file as well. Difference type. Yeah, why am I saying random access iterator? I, yes, difference type is, who remembers this? Traits of I. Yes. Full points too. Ryan. All right, so we have difference type. We implemented our increment, and we want, okay, difference is the other one, right? Distance, difference. What have we decided on? Difference type. This difference. Okay, and how does this go? Position minus y dot position. Maybe I should move it to the next line. Might be a good idea. Yes, excellent. As const. That's it for our basis, I believe. All right, now we need to implement a lot of operators. What can you do to a random access iterator? Let's start with the simple ones. Let's start with square bracket. What does it return? Reference. And what does it take? Difference type. It takes int, are you sure? Well, we can look it up. I'm not 100% sure. Well, in the, it has to be convertible to int, yes. But the fact that, yeah, I guess it has to be convertible to int, that's true. I don't know what the standard defines. You can always look through it and see what the STL actually says. And I, doing I. Let's define difference type because it's not defined right now. Go up and difference type. All right. And how do we implement this? I think this was a bad choice actually, but yeah, because plus equals is how you would want to implement this in terms of plus equals. So Ryan, why don't you tell me how to implement plus equals? star this, yes. And now we can do this easily because we can say, how do we do this? Copy what? Yeah, you have to say what it is. Are you sure about that? I think that's correct. All right. What else? Minus. Okay. What else?
Why do we use minus equals if we don't have decrement? Anybody can do plus equal with negative now.
People would write minus equal.
The language supports a minus equal operator. So let's say, yeah, I mean, if it's the same question, right? Let's say you were dealing with some code that was doing, f plus equal minus some business, right? And you say, why? This is unnecessarily complicated. I'm going to change this to minus equals this, and you would expect it to work. And you would be very upset if I told you, no, my iterator class does not support minus equals.
Why doesn't the same argument work with decrement?
What do you mean?
Implementing.
Oh, yeah. Decrement is something that, I mean, what should we call it?
So yeah, I've called it offset when I've implemented this before. Instead of increment taking the value, I call it offset taking the value.
Yes. Okay, so you're saying.
So then it's not confusing because you don't think offset,
Mhm.
Negative offset makes sense, and negative increment is kind of
Is problematic. Okay, let's change the name. I think that's a good argument. Offset, right? Where is it? Okay. So later, does this make sense?
Okay.
That is, we should, absolutely. Tell me what to type. Start this minus plus equals minus I. All right, excellent. What do you mean?
You change your plus plus to offset, right?
No, we don't want to do that because we want this to be usable with a with a forward iterator as well.
So if you do use it with the forward iterator, will it? I guess what errors do you come across until will it compile just fine until someone tries to use one of these things?
So this comes back to the old question that we ran into when we were doing equals, right? Remember when we first implemented equals for pair, we made it a friend function, but then we realized, oh, the requirements on T1 and T2 are that they are semi-regular and not regular, right? So in C++ as it exists today, nothing is checked about what types you're passing to a template. But when the template is expanded, at that point, the expanded code needs to compile. So when you do plus equals, the compiler will say, oh, that means I need to do basis dot offset, and is offset defined on my basis? If it's not defined, that will be a compiler error.
So would you have to implement multiple versions of this if you wanted to be? I guess is it a compiler error if you don't actually use the functionality?
No, it's not.
Okay, so it's only.
Yeah. So as long as you don't call it, nobody will mind, and it'll be okay. Yes. But if you call it, then it'll be an error, and it'll probably be 5-page long. And yeah. But usually, what happens is it's not just that you call plus equals. What will usually happen is that you will call some algorithm which depends on plus equals, and it'll probably depend on it by calling like 5 other functions. And so the actual error happens deep inside somewhere, and there it says, oh, I don't have plus equals, and therefore what you get is a really long error message.
And this is true because it's in a template, so it's the template expansion where this gets failed.
Yes. All right. Plus equals, minus equals, square bracket. What else do we need to define? All the operators as friend functions. Yes, as in all the comparison operators. So, friend, bool, operator less, const.
Do we need the construct operator as square bracket?
Do we? Oh, you mean the? Oh, well, this it should be const as well. It doesn't modify the state. No, don't we need it in both places?
You want to
No. That bracket's the name of the function.
Yeah, that's the
You
spec.
need
want
it
it
at
after
the
the
end. You
parameter.
want it after the print.
Yeah.
Oh, right. Not thinking clearly.
It's hard to type and think at the same time.
That's
That's my excuse for all my problems.
Should we have a version of this operator that returns not the reference but constant reference?
How to define const iterators using this is an interesting question that is left as an exercise to the reader. Yes. But yeah, we do need to ultimately make this handle const iterators. I haven't thought enough about it to.
If you say, oh, I need an iterator to const int, then it'll just work.
The reference type will end up being const, and therefore.
Your reference in that case would be a reference to a const int, and this function would work, and then if you tried to actually modify reference, that would be a compile error at that time, but the function itself would work.
I think John's argument makes a lot of sense. I have not tried it myself with a const iterator, but I think it's very reasonable that it could work. Yes. If we have time at the end, we can try it, if you're feeling adventurous. But first, let's write less than. Iterator, ref x. Okay, how do we implement less than? But we said state was semi-regular. Oh, sorry, the basis was semi-regular. The state, it has to be less than comparable. But we already defined difference on the basis. So shouldn't we just use that? All right, so tell me how to do it. If y minus x is greater than 0, then then y is greater, right? Return y minus x is greater than 0. That, of course, brings up the interesting point. Will this compile? We haven't yet implemented minus, so we should probably do that. Since we need minus anyway, I think it'll be better to.
You would call it different.
Yeah, difference. We call it difference. Put this in terms of difference.
Minus should be implemented in terms of difference, but less than can be implemented in terms of minus, for the same reason that we implemented minus equal in terms of plus equal.
I think we're in agreement.
We're in agreement.
I think it would be more clear if we say x minus y is less than 0. Because it's operator less.
It's operator
It's
less.
semantic, but I'm less than
Maybe. The problem then is you get a negative. Yeah, but negative things should work. I mean, I don't have a strong preference either way. Does anyone have a strong preference either way?
I think we should use the less operator. Yeah, it's more natural.
Okay. On the other hand, I could argue that the less than means that y is greater, and therefore, I mean, no.
Oh boy. Good thing Alex isn't here.
Okay, I'm going to change it. Minus y is less than 0. Somehow this looks more unnatural to me, but if all of you like it, then I'm okay with it. Why do you like the other one better? Yeah, reasoning with negative numbers is hard, right? It's just y is greater than x. Y minus x is greater than 0. It's very simple. I mean, what do you learn first, 10 minus 5 or 5 minus 10? 5 minus 10 is unnatural, right?
Maybe we should implement greater than first.
Well, greater than has a trivial implementation because it's implemented in terms of less than.
He's saying we should do the opposite.
We could do the opposite. Maybe we can make this. He said we should keep a list of things we can't agree on. So we could discuss this with him. All right.
Well, this is not.
Can you instead do 0 is less than? Requiring algebra and then symmetry instead of just one or the other, right?
So how would I'm not clear on what you are proposing that we write.
0 less than y minus x. Because then you can say, oh, I'll just put the x on the other side, and it's what I expect.
Isn't it better just to put y on that?
I think we can have an extended discussion on this in the next lecture. All right. Less than, greater than. This should not be controversial. Valera, how does it go?
Greater than, return a greater less y.
That's very equal.
Not, or not a greater less x y.
All right. No?
not less than
Less than x.
That's what I said.
Okay, we can do that. Y is less than x. Is this satisfactory? Yes. All right. And not y less than x. I think that works. And we need greater than and equal, which is not x less than y. Yes. All right. we have all of the comparators. I think at this point it's clear that an adapter class is very useful. I think we would all agree. Yes, Hernan? Okay. We still need minus and plus. We haven't implemented plus, right? So let's do that. Go ahead. Yeah. I don't know. Well, what does minus? Should we do minus first? All right. What does minus return?
Minus returns difference.
Difference type. Difference type operator minus, and it takes another iterator, const iterator ref x. All right, and what does it do? It's a friend. It's a friend. Oh, it's sorry. Yeah, we have to implement both. We have to implement both. Okay, so this is definitely no wait. Minus should be implemented as a friend. Yes, it's symmetric. So we should not be implementing methods here. We should just implement a friend function and be done with it. And therefore, we need to change the signature to take 2 of these. Iterator ref y, right? Ryan is unconvinced. What don't you like about this, Ryan?
The fact that in a friend function we are accessing the basis state.
Yeah, public. Well, okay, so let's implement it and then we can talk about whether this is a acceptable thing to do or not. Well, okay, let me make multiple arguments there. What does it mean to be a friend function?
Yes, you have access. In this case, it's not symmetric because we're going to call x dot basis dot difference of y.
Well, it is symmetric because we expect to use the same answer.
Well, no.
Anti-symmetric.
Why? Yeah.
Minus. Yeah. Yeah. Return x dot basis dot difference y. I mean, minus is not a symmetric operation. That's just the way it is. Nothing can be done about that.
That's why we do it as friend.
But you do need, oh, so you would implement just the operator minus?
It's called difference on y basis.
Thing is, you really get 2 operator minuses because you can subtract a difference type to get a different integer.
Yeah, because
Subtract an integer to get a difference.
I'm not sure you can do that. Can you write 5 minus pointer?
No.
You can't write that. It's not allowed.
Right, pointer minus 5.
You can write pointer minus 5.
That's what I'm saying. So we need to be able to subtract
2 pointers as well as, yes. So we need one other minus function, certainly.
That minus returns a reference, or an iterator. If I do iterator minus 5, it's getting me back an iterator, it's not getting me back a difference.
Yes. So let's implement that.
It's y dot basis in that line, right?
yeah.
It's x minus y. Yeah, y?
It's basis of difference y dot basis.
Oh, yes, that's correct. Yes. All right, the other minus we need is with difference type. And here I would,
It is not a friend, it's not. It's going to return a reference.
and it's going to return a reference, yes.
Or sorry, not a reference, iterator ref.
Yes. Iterator ref. reference type I.
No first argument.
And no first. Okay, I should just have written it from scratch, but too late. And how do we implement this?
Iterator temp equals star this.
Oh, you don't want to be, you're not returning the reference to the iterator, you're going to return a copy.
Yes? What else? Wait a minute. We are defining, oh, minus equal is already defined, yes. Yes, I believe iterator, make a temporary copy, subtract, return. I think that works. I think we should add whether this should be a method or a friend to the list of questions, because I'm not sure about that, but something we can talk about.
Should there be operator plus that would implement this and operator minus would use that?
Let's define operator plus and then we can ask the question. So we had a minus, let's write a we need a lot of different pluses. So let's write all the different pluses and then let's look at this again and we can answer the question. All right. No, I should just write it from scratch. That was a mistake. Okay, so what are the different kinds of pluses that we need?
We don't want to add two iterators.
Yeah, that would
Two iterators, and you cannot add them. Yes, that's not allowed.
We just need the one that's not the first. The equivalent of what we have above.
So we need the equivalent of this in two forms, right? We need,
Why do we need two?
you can write I plus 5, and you can write 5 plus I. Right? No? Yes? You can definitely write 5 plus I, yes. You can even write 5 square bracket I, but let's not go there. Okay, so this thing will take friend operator plus const iterator ref. So we need these two. Actually, okay, how do we write this? This is really easy. And the change I made gave you a big hint.
X plus equal Y, I. Return.
Yes, we could do that. Why not? All right. Return, same thing here, x plus equal I. Are we done? Is that it? I plus x, x plus I. What?
Why can't we use the operator minus to do the plus? To do minus of minus I.
Why can't we use minus to do plus?
People will type plus equals. The language supports it. So we need to define operator.
I would say I think it's simpler to just implement minus in terms of plus. We should do that. Does that make sense? So here we can just write return star this minus I, right? Much simpler. Plus minus I.
Now that we have plus, we can re-implement bracket.
Yes, and in fact we never implemented bracket because we said we would implement it in terms of plus. No, we did implement bracket. Yes, but we should implement it in terms of plus. Absolutely.
Star this plus I.
Yes, perfect. I think that's. Yeah, I guess we could. Yes. Difference type. You mean with my? Oh, with a square bracket? No. Yes.
Implement a friend operator square bracket, which takes a difference type as the first parameter, and an iterator as the second parameter.
Iterator X.
Roll must not smile.
And
Except it's not this. You can't use this. You need to do X instead of this.
Yeah, X bracket I.
Oh, yeah.
And you don't want that to be const.
why not?
Well, because it's not a member function, so it can't be const.
Function can
Function itself can't.
The function itself can't be const. Absolutely. It's a friend. This should just say X of I. I think we're done with this. Okay, so there are only 3 minutes left, and I'm not brave enough to try to compile it right now. But I will fix all the simple bugs and check it in. So now that we have this, we can write a lot of interesting iterator adapters, and we'll see. Maybe we'll write some in the next class.
So when you did the basis, can you slide down where you implemented basis? So there is this handy iterator class in the standard where you just say you want to derive from this template, and it will define those type defs for you. Not all the ones we hit, because it doesn't have state type, but it has all the ones that the standard expects.
Oh, okay.
Was there a reason you didn't do that, or you just wanted to? I mean, this was a good exercise to step us through it, but if you're actually going to do a lot of.
Was it added in C++11 or?
Yes, yes, it was.
Oh, is it?
Yeah, it was in TR1, I think.
Oh, okay.
Okay, so I'm not aware of it. Okay, can you send an email to the class list explaining it? Because I think that would be a useful thing.
It's not exactly the same. I tried using it before, and it wasn't quite the same. But
You just have as template parameters the things that you want to declare these type defs for. It just does that for you.
Mhm.
It's not. It saves you a little bit.
Okay, and Boost certainly has libraries to define iterators, which with the same kind of idea, you define a few fundamental functions, and it gives you the full iterator. A few years ago, when I first looked at that thing, I could not understand it. But I think once we've stepped through this, I think now you should be able to read that and actually use it.
Once you've done it the hard way,
Yeah.
you appreciate what they're doing for you. It makes sense.
Yes, absolutely. But now that we have this, we can think of. I mean, so for instance, it would be trivial to implement a reverse iterator using this, which would iterate in the reverse direction. You could implement a transform iterator, which just says, okay, take whatever we are pointing to, square it, and give it back to me. There are a few questions in both of these. Maybe we'll actually implement them next time, because both of those bring up some interesting design questions that we will run into when we do our variable length container. But that's it for today. Oh, next.